We see an incomplete entry for Linux CBT deb2 because it's currently not turned on for an IP address of .175. And we see an entry for Linux CBT Media 1. Wherever possible, name resolution takes place. So here's the layer 4 information, Linux CBT Media 1 for its IP address, which translates to its MAC address. But no need to believe the MAC or the ARP table's entries. Connect to the host and examine for yourself. So for example, for this 199 host, which is a Red Hat Enterprise box, we should still have an SSH session open to it, and we do. That's here. Let's clear screen and execute ifconfig. We will see that the MAC address terminates with 1692. Let's see if that's the case here. There it is, 1692. So our local system knows how to get to 192.168.75.199 using Ethernet 0 and the following MAC address, which terminates with 16:92. And we've confirmed using ifconfig on a remote system that indeed its MAC address ends with 1692 and its IP version 4 address is indeed 75.199. We may also confirm the MAC table, the ARP table on the remote system by executing ARP-A. It should include an entry for our host system, .10, with its MAC address, and it does. But no need to believe the ARP table. Return to the local system, execute ifconfig, and you'll see that indeed 4108 is the MAC address. So when two hosts communicate, they exchange MAC information. This returns MAC to IP mappings. So note, when two TCP/IP hosts communicate, ARP is performed to translate the IP address, and this may be v6 or v4, to a MAC address, which is layer 2. Also note, if one or more routers separate the communicating hosts, which means there's hierarchy or subnets involved, then the MAC address of the router's interface is stored by each client. And we should note the MAC address of the default routers or gateways interface is stored by each client, and then the router is responsible for translating subsequent lookups of IP addresses to MAC addresses for subsequent routers if necessary. So as the hops are translated, for example, if we communicate with an internet site from our internal box, we indeed find out the MAC address is the interface of the router because the IP address is on a remote subnet. So we store that MAC address of the interface of the router. Then the router goes ahead and looks up on the internet its next hop and stores the MAC address of the next hop. Then the next hop stores the MAC address of the next hop until it gets to the destination. All this tends to occur within seconds. So for example, in a simple connection like telnetting to www.linuxcbt.com port 80, all of that takes place. As quickly as we were able to say so, our local system, the .10 box, stored the MAC address of the router. The router stored the MAC address of our ISP's router, default gateway that is, and up through the chain until we get to our servers, which are based in San Diego. So just like that, the internet has placed us there. And that is a result of the ARP translation taking place. And each and every TCP/IP compliant device performs this sort of ARP or address resolution lookup whenever two hosts attempt to communicate. Now there are many more tools to look at. What we'll do is sprinkle the usage of those tools, such as traceroute, MTR, NSLOOKUP, dig, and so on, whois, etc., throughout our studies, rather than spending too much more time focusing in on those key tools. Again, let's just recap some of the important tools that we've covered. And they're diagnostic tools, of course. From the top, we looked at ping. Ping is the Packet Internet Groper. It sends ICMP, which is a distinct protocol from IP and TCP and UDP. It sends ICMP echo requests and expects echo replies, and it can be customized to send certain packet sizes, certain counts, certain intervals, so on and so forth. Use it to test whether or not a host is available. But it doesn't always work. Beware. Note, firewalls, one or more, may block ICMP traffic, causing the pings to fail. Telnet is great for diagnosing TCP ports. It helps you to connect to the TCP port and determine very quickly whether or not the port's available from the perspective of the user testing. So if you're out on the internet and you want to determine if a box that should be published from our network is accessible, try to telnet to the port that you know is to be accessible. And if you can connect, then you know you have connectivity. Netstat returns connection information based on information in procnet. Again, the kernel maintains information in this dynamic file system beneath proc, and beneath procnet are many 0-byte files that are dynamically updated that Netstat relies on to return information such as current listeners, established sockets, interim connections, or even the routing table, which we haven't shown you. Netstat-rn, for example, returns our current routing table, which tells us that our default subnet is accessible via ETH0 with the following mask, 24 bits. The subnet for automatic IP configuration is available on ETH0 if necessary. And for all other hosts that don't match these two subnets, send the traffic to our default gateway of 192.168.75.1, which is also accessible through ETH0, and it's up and it is a gateway. The U status means the route is up. Let's just add this to our netstat series of commands because it's important, although you could run the route command. So netstat-rn returns the routing table. This is the kernel routing table. In other words, the kernel uses this routing table to determine how to route traffic, depending on the request that's made. So when we issued the telnet to www.linuxcbt.com port 80, immediately the kernel determined, well, www.linuxcbt.com translates to a 71 address, 71.6.192.197, which doesn't match this network or this network, so it has to be sent using this catch-all to our default gateway. Our default gateway, which is the router, then took it upon itself to go and look up on the internet how to get to 71, so on and so forth, 6.192.197. So netstat is useful for determining connectivity information, including the routing table information. ARP, especially when run with the -A option, returns the MAC to IP mappings, and it is useful in determining who those hosts are. ARP is always maintained in a TCP/IP setting, as it is the base or the low-level layer 2 protocol that's used when communicating on various network segments. Again, when you communicate with a remote host who resides on a different subnet, your system will maintain an ARP entry for your default gateway's interface. Your default gateway, which is usually a router, will then determine how to communicate with, in other words, it will relay the communications to its default gateway until it gets to the destination host. Again, this all happens within a matter of seconds or less, since the connections are small and the internet's fast. So those are your key tools, but there are many other tools, many other tools. These are just tools that you'll use frequently.